Hey everyone, and welcome to this explainer. Today, we're going to completely demystify web hacking by peeling back the layers of how the internet actually functions. So often we look at cybersecurity and think of it as some sort of dark art or a magic trick, right? But the truth is, the absolute foundation of a real world bug hunting is firmly rooted in understanding the standard everyday plumbing of the internet. By the time we finish today, you're going to see the web through an entirely different lens. Here is our roadmap for today. First, the bug hunter mindset. Second, vulnerabilities and bug bounties. Third, clients versus servers. Fourth, the rules of communication. And finally, we'll look at the anatomy of a web visit. Let's get right into it. All right, part one, the bug hunter mindset. Let's start with the psychological state you actually need to break the web. See, hacking isn't some kind of dark magic. Really, it's a gritty, curious hunt for unintended actions out in the wild. As Peter Yaworski outlines in his excellent field guide, Real-World Bug Hunting, a successful hacker basically needs 1/3 knowledge, 1/3 observation, and 1/3 perseverance. It's not about typing furiously into a green and black terminal like some Hollywood movie. It's about deeply observing how an application works and asking yourself, what happens if I do this instead? Matthias Carlson really hit the nail on the head when he said, approach every target like nobody's been there before. This mindset completely challenges you to look at the web differently, exploring way past the intended functionality. When you're looking at massive, mature sites like Google or Twitter, man, it is incredibly easy to get discouraged. You think, well, everyone else has already looked here, there's no way there are any bugs left. But here's the thing, developers are constantly writing new code, they're adding new features, and yeah, they are making new mistakes. You absolutely have to assume there is always a stone left unturned. Moving on to part two. Vulnerabilities and bug bounties. Let's get our terminology straight before we look at the actual machines. So, what is a vulnerability really? The crucial point here is that vulnerabilities exist simply because of weaknesses left in the code. A vulnerability isn't necessarily a broken server or a crashed database. Often it's just a piece of code doing exactly what it was programmed to do, but without the proper guardrails in place. Think about it like this. It's a door that was accidentally left unlocked, or maybe a VIP pass that just wasn't properly checked at the entrance. You've got to train your brain to look way beyond what the developer wanted, searching instead for how existing features can be completely abused. For example, imagine a developer builds a system to keep your profile private. Okay, that's the intended action. But let's say they also build a feature that lets people add friends. If that add friend feature is poorly coded and allows someone to literally force add themselves to your list without your approval, they instantly gain access to your private data. That is an unintended action, and finding those exact dApps is the core of bug hunting. And here's where it gets really interesting. When you ethically disclose these flaws, companies actually reward you through formal bug bounty programs. And these rewards, they are no joke. They can range from tens of dollars to literally tens of thousands of dollars for a single bug. Companies like HackerOne and BugCrowd facilitate this whole process, allowing ethical hackers to get paid real money or sometimes service credits or air miles just for helping secure the internet. It turns what used to be a shadowy hobby into a highly lucrative, deeply respected profession. Okay, part three, clients versus servers. Let's peel back a layer and look at the primary machines involved here. At its core, the internet is just a giant network of computers sending packets back and forth between two very distinct roles. On one side, you have the client, that's you, right? You're typing away on your laptop or tapping on your phone, initiating a request. On the other side is the server, the remote machine sitting somewhere in a data center, receiving your request and figuring out what to do with it. Every single bug we hunt for exists in the space between these two machines, or in how one of them handles the packets sent by the other. Which brings us to part four, the rules of communication. To understand where these bugs live, we really need to understand the rulebook that governs this invisible conversation. Without these RFC guidelines, requests for comment, the machines wouldn't even know how to agree on the data being sent. I mean, imagine trying to have a conversation where one person speaks French, the other speaks Japanese, and neither has a clue what the other is saying. It would be total chaos. RFCs are basically the universal translators of the internet. They explicitly define standards for how computers should behave, ensuring that a packet of data sent from a browser in New York is perfectly understood by a server over in Tokyo. Now, what's absolutely vital here is that HTTP forms the foundation of almost all the web vulnerabilities we hunt for. HTTP is an RFC standard that strictly defines the format of the messages passed between the client and the server. As a bug hunter, you aren't just looking at the pretty web page. You are actively intercepting, reading, and manipulating these raw HTTP messages to see exactly how the server reacts when you break the expected rules. All right, final section, part 5, anatomy of a web visit. Let's zoom way in on the exact step-by-step process of visiting a website and kind of slow time down. In mere milliseconds, these 6 invisible steps execute perfectly just to load a single page. When you type google.com and hit enter, your browser extracts the domain name. Next, it figures out the IP address. Then it reaches out and establishes a connection. It fires off the HTTP request for the page. The server processes that request, sends a response back, and finally, your browser renders the response so you can actually see the search bar. Hackers look at this rapid-fire workflow and figure out exactly where they can sneak themselves into these specific steps. Let's double-click on step 3 for a second. During this step, TCP connects to specific ports, which basically act as designated doors for different services running on the server. Think about it. A server might be running a website, an email service, and a database, all at the exact same time. So how does it know where to route your incoming packet? Well, it uses ports. Port 80 is the standard door for unencrypted web traffic, and port 443 is the door for secure encrypted traffic. If a server administrator accidentally leaves the wrong door unlocked, a hacker's absolutely going to walk right through it. Step 4 is totally critical for us, because manipulating these request methods can trigger all sorts of unintended actions on the server. When your browser asks the server for something, it uses a method. A GET request is supposed to just retrieve a web page without changing anything. A POST request is used when you submit a form or log in. It invokes an action. But here's where the bug hunting comes in. What if a developer accidentally codes a GET request so that it updates a database record? An attacker could just trick a victim into clicking a standard link, and boom, their account settings are completely changed. When the server replies in step 5, it gives us these 3-digit codes that tell us exactly how it handled our request. If you get a 200 series code, it means, okay, we're good, everything worked. A 300 series means look somewhere else, which is how redirects happen. A 400 series is the server telling you, hey, you messed up or you aren't allowed in here. Think of the famous 404 not found, right? And a 500 series means the server itself crashed or had an error. As a bug hunter, you are constantly monitoring these codes. Like, if you manipulate an input and suddenly trigger a 500 server error, you might have just found a critical flaw in their database logic. Now, this brings us to a massively important concept. Just like that movie 50 First Dates, the server has total amnesia. Actually, a better way to put it is that HTTP is completely stateless. Every single HTTP request is treated as a brand new conversation. The server has zero memory. If you log into a website and then click a link to view your profile, the server has completely forgotten who you are in the split second between those 2 clicks. It treats your second click as a totally new visitor. Crazy, right? So, to prevent you from having to type in your password on every single click, sites pass cookies with your requests. And you guessed it, this is another prime target for bug hunters. Because the server has amnesia, your browser has to remind the server who you are with every single packet it sends. It does this by attaching a little text file called a cookie. So if a hacker can find the vulnerability that allows them to steal your cookie, they don't even need your password. They just attach your cookie to their requests, and the server says, oh, hey, welcome back. So now that you know all this hidden plumbing, how are you going to look at your next web visit differently? We've peeled back the layers of clients, servers, ports, HTTP methods, and stateless amnesia. You now have the foundational rulebook of how the web actually communicates. As you browse today, look at the URLs, think about the GET and POST requests happening invisibly in the background, and ask yourself, how could I manipulate this? That right there is the essence of the bug hunter mindset. Thanks so much for joining me on this explainer, and keep exploring.